Pytorch and Tensorflow, two great and leading deep learning libraries used extensively by OpenAI, Google, and Meta. And they're pretty good rivals, so I'm going to be going over both of them, looking at each of their features and their libraries to see which one is the better library. Let's start with TensorFlow. TensorFlow was developed at Gaggle from the Gaggle Brain team. You see, TensorFlow was pretty revolutionary for its time. It had features like training on multiple GPUs, TensorFlow Lite so that it could run your models on like Arduino and IoT devices, and much, much more. But it's kind of old, so people call it Unk, and that's why they go to Pytorch, which we'll talk about later. If you have a web browser and a Google account, you can simply go to Google Drive and create a new Jupyter notebook and open it in Google Colab, which supports TensorFlow right out of the box. So the way I'm going to use a GPU is I'm going to click here at Runtime, go to Change Runtime Type, and click on T4 GPU and then save. This will make training a lot faster. You can obviously do matrix multiplication with TensorFlow as shown here. It's pretty easy, thus you can make yourself your very own neural network. But most of us are just too stupid. So we have Keras. This is how we actually make some decent neural networks. First we import TensorFlow. Then we create our training set and our test set. We can do this by importing the MNIST datasets from the Keras Datasets API. Next we'll define our model using the Keras Sequential API. This will let us define our layers line by line. Our input layer will be a flattened layer. The input shape will be 28 by 28 because that's the size of the image is 28 by 28 pixels. For our hidden layer, we'll have 64 neurons. You can make this whatever you want. And our activation will be ReLU. You can change this to be whatever you like by just going tf.keras.activations.whatever. You can do leaky ReLU, tanh, swish, mish, jish, fish. Finally, for your output layer, since we have 10 digits, 0 through 9, we'll put 10 neurons and use softmax activation. Finally, to train our model, we'll call the model.compile method. We'll set the optimizer to be a stochastic gradient descent with momentum. We can make this Nesterov accelerated gradient descent by simply setting Nesterov to true. Finally, we'll set our learning rate to 0.01. For our loss, we'll do sparse categorical cross entropy. Finally, we'll set it so that during training, it'll show us our accuracy. Finally, we'll call the model.fit method. We'll set our training set to xtrain and ytrain. We'll make it train for 20 epochs, and we'll set our validation data to be our test set. Callbacks can also be implemented. For our example, I'll make it early stopping so that it stops when the accuracy goes down to prevent overfitting. You can also make it save during certain checkpoints. After 20 epochs of training, we can get 96% accuracy from our neural network. But is Pytorch any better? Pytorch was developed in 2016 by Meta, so it automatically sucks. I really don't know much about it except that it has pretty graphs. That's literally it. And TensorFlow has that, but with TensorBoard. They even made a cute name for it. It's called the Discrete Acyclic Graph. All it does is show data move through the network. It is not as crazy as the name implies. First we import TensorFlow just to get our data sets, and then obviously Pytorch and all those libraries. Next, we will define our data sets. The only way we're going to do this is through the tf.keras.datasets API. And that's because I don't really know how to use Torch Vision, but that's alright. Next we'll use the Tensor Dataset API and the Data Loader API just to make it so that the GPU that we train on will train easier. Next we'll create a class defining our model. In our init function, we'll have our inputs, our hidden units, and then our other hidden units, and then our classes. And then we just create a simple sequential network from there. And we'll create a forward method. This method will show how the data will move through the model. Now, because Pytorch doesn't offer a training loop, we have to build one from scratch. Yep, that's great, thank you. Anyway, this is a very simple one that you can just pause the video and copy, and I didn't really show the loss on here, but you can also do that if you want. Finally, define your model, define the optimizer, define the loss, then call the training function, and you're done. Now, you just saw me completely glaze TensorFlow and completely dunk on Pytorch, which is kind of unfair. You see, Pytorch is great, and those pretty graphs are actually very useful, and defining your very own training loop is actually great because it gives you a nice sense of clarity. All things said, choose Pytorch if you want a great sense of control, and if you plan on getting a job, use TensorFlow.
And subscribe.